Howdy guys, my name is John and today we're going to be looking at how to modify single cycle data paths and we'll be looking at PastExam1 problem number 7. Okay, so here we're going to be wanting to add a new I-type instruction, SWPI. There's the assembly code for it, and let's see, SWPY. Store word post increment performs the following operations. The word stored in register RT is loaded into memory location specified by register RS. And the word stored in register RS is incremented by IM immediate, and stored back into register RS. Okay, so we're going to want to do both of these operations down here in order. So the first one is that we take the word stored in RT and we load it into the memory location which is specified by register RS. So we take RS and set that address, the memory address, we set the memory at that address to the word in RT. Okay, so to go ahead and do this instruction, let's go ahead and do this first part. So we're going to want to load RT into the memory specified at address, the word that's in RS. So we start here with RS, and we go ahead and go through our ALU, and that needs to be our address that we're using. And I'm going to go ahead and extend our mux here, add a new value, and set it equal to 0. Okay, so what am I doing here? I'm having it to where RS is added with this new value, 0, so then we'll be reading just from RS by itself and nothing else. Okay, and so now we have the memory, or we won't be reading from it, we'll be writing to it. So we have our address that we want to write to, and what exactly do we want to write to it? We want to write the word stored at RT. So we just take this word stored at RT and put it in our write data in memory. Okay, so we've done this first part of the instruction. What's the second part asking? It's asking us to take the word at RS and add it with our 16-bit immediate value. Or, let's see, so we take our immediate value. Okay, so we'll have our immediate value. It goes through the sign extender, so now it's 32 bits. Let me just clean that up a little bit. Okay, so we take this value at our 32-bit immediate value, and then we're going to want to add it with RS. So we can just take RS over here, take our immediate value, and then I'm doing my best to draw an adder, but this here is an adder. And then we take this added value of RS plus the immediate, and then add it into this mux. So we'll go ahead and extend our mem to reg mux to have this value down here of RS plus immediate. So then coming out of here is going to be RS plus immediate, and it's going to go to our write register. And the register we're going to be wanting to write to is RS itself. But we can't do that right now, so what we're going to have to do is also extend this mux, and then we'll take our RS value into this mux, and that becomes our write data. So far we have made 4 significant changes into here. So now we can go ahead and answer the questions we have. Okay, so did we make any changes? Yes. Yes, we did. So what changes did we make? Okay, let's see. So let's go from left to right over here. So we needed to add rs, and I'm not putting the $sign because we're not reading the memory at rs, we're reading just the address to the register itself. So we're adding rs to the register destination mux. We then have to change our ALU source value, so add 0 option to our ALU source. And what adding that option, what the 0 value does is just ensure that the only part of the address that we're reading is just rs. So the address that you want to write to is just rs, and it doesn't have any shift amount or anything in it. It cannot have a shift amount. Okay, so we add that option, and then the next part of the instruction is that we want to add rs, the word at rs plus this immediate value that we defined. So we have to add an adder for the immediate and the rs. Okay, and then that value will then be added to the mux mem to reg. Okay, so basically what this means is that we take our immediate and we take rs, we add them together, and then we put that into this mux. And so then that can become the value of the register that we write to. And then, so we'll be saving that value to our register, and we'll also be saving this value rt to address rs in our memory. Okay, so we kind of already answered part B. Any new or expanded control signals. So no new signals, but we will be expanding, let's see, we'll be expanding register destination, we'll be expanding ALU source, and we'll be expanding mem to reg. Okay, and each of those are going to then have 2 bits each. So now we can go ahead and answer part C, which just defines our the control signals we'll be using. Okay, so register destination. So since we added rs to register destination, we know that it needs to be the last value, which is 2. So 2 in binary is just 1, 0. Our ALU operation is just going to be the same as a regular store word operation, which if we pull up, we will see that a regular store word operation is just 0, 0. And why do we know to use that? We know to use it because it tells us that since it's an I-type instruction, it doesn't have a function code to define what ALU operation it uses. So it's just defaulted like a regular store word operation. Our ALU source, we said we're going to add this value, so it's going to be this 0 value. So that's going to be 2, which is 1, 0. Mem to reg is also going to be the exact same as those. It's going to be the new option we added, so it's going to be 1, 0. Register write, we will be writing to register, so that's going to be 1. The register we're writing to is RS. Memory write, yes, we will also be writing to memory. We're going to be writing RT to address RS. And we can't read and write at the same time, so read is 0, and we won't be branching, so that is 0. Okay, so this one was a little bit confusing, but I think we kind of understand now that whenever you're given a problem where you just got to do two separate things, just make sure to do one and then try it and accomplish the next. Alright, thanks and gig 'em.